For today's agenda, I want to give you a high-level overview about what is Snowflake and how Snowflake is unique compared to other cloud databases in the market. Plus, also I want to give you a high-level overview on Snowflake architecture, and I'll show you how the Snowflake is helping the customers in different ways, and finally I'll also show you like what is the course curriculum which are going to cover as part of this training, and I give you the time for you to ask some questions in the end. And just to share my screen, just let me know you are able to see my screen. So when I talk about like uh, Snowflake, right? Before understanding about Snowflake, I hope you have some fundamental idea about data warehouse. So when I start talk about data warehouse, so data warehouse was very old, and where people started a data warehouse usage in very long time ago. And when I talk about uh, data warehouse, the conventional data warehouse, that was not available from the starting. Before 2000, there was only databases where people were only focusing on how to extract the data and then how to load the data into the databases. That was only the task people are majorly focusing. And they used to store the data and they used to extract the data. The two, they used to leverage that data for their application development and all, and building their applications. When I talk about analyzing the data, the main challenge came into picture when people started thinking like how to analyze and generate the reports, because the real-time data will be most frequently changing. The analysis is not easy because the analysis always will go wrong. So people started thinking, how can I go and overcome that challenge? That is where the birth of big data, data warehouse, has been started. And as soon as people started thinking about data warehouse, the tools like Informatica and Data Stage, SSIS, BODS, all this came into picture, and every company started using them to separate their real-time data into another database, and they started calling them as data warehouse, and which contain historical data, that to past data. So every data warehouse will have only past data. To maintain a data warehouse, we need to go and refresh on a daily basis or weekly basis after business hours, and people used to run some batch jobs and they used to refresh the data warehouse incrementally every day or every week. But when people started converting or migrating to data warehouse, people also started learning other tools like crystal reports and business objects and MicroStrategy. These tools are also were very famous to generate the reports. As soon as my data will come and sit on the data warehouse, I also need to know how to utilize that data and help the enterprise companies to use the data and generate some reports, and on top of it take some decisions. So this is where the reporting tools also came into picture after ETL tools came into picture. And most of the data for this data warehouse, like to build the data warehouses, is internal data only, because in early 2000s there was no any type of unstructured data or semi-structured data. There was only database specific data, RDBMS data, which is in the form of tables, which is rows and columns. So a predefined structure was there, and some part was only plot files and CSV files. And people who wants to work on this particular data warehouse also, they should know ETL, any one ETL tool like Informatica or other ETL tools, plus one database. So that is what the requirement companies were looking for. So every company who wants to build a data warehouse, they used to hire ETL developers who knows one of the ETL tool and one database. If you want to work on any database like Oracle, you should know SQL and PLSQL. And if you are working on a database like SQL Server, you should know that TSQL, which is called Transact SQL. So these are very mandatory during that time period, and people started leveraging the database knowledge plus ETL and then they started building conventional data warehouse. And the data loading was also, someone is saying something, just give me a minute. Okay. And data loading. So when people started loading the data into data warehouse, so people started like only it as batch loading, and the data was only people used to load on daily basis or weekly basis by running some batch jobs in the background. That too after business hours, because if you do during the business hours, it will impact the real-time environment. So people were waiting for the daily business day to complete, and then they used to wait for the transactions to come into the real-time environment, and then they used to perform the data warehouse to be refreshed. That is what the practice people used to follow. And after the data warehouse was refreshed, people also leveraged this data to build some kind of applications like revenue leakage fixing and potential customers prediction. These kind of applications were also people started building. This was happening only on conventional data warehouse, which is a traditional data warehouse. If you go to 2010, right, we experienced so much big revolution in the data side, where we got big data into picture. The reason behind that is so much amount of data got generated during this time period, because there was so many social media applications got emerged, like Facebook, Twitter, Instagram, YouTube, WhatsApp, and many different social media companies they started, and everybody started leveraging that particular applications, and everybody started uploading videos, images, documents, all this stuff. And ultimately what happened, the data growth became very high. Within a span of 2 years, people experienced so much amount of data growth, plus also there were no tools to manage this, so big data came into picture. Wherever people are only focusing on structured data, after 2010, the same ETL developers got to work on unstructured and semi-structured data also. Unstructured means videos and images and documents, and semi-structured means we also have semi-structured data like JSON files, Parquet files. These kind of files also came into picture after big data came into picture. So as a ETL or data warehouse engineer, we need to go and even process any kind of data. That is how the market is running now. Not only database tables, sometimes data may sit in semi-structured format like JSON and Parquet and other file formats, or it will even store in the like a big data warehouse in the form of unstructured format. So because the reason behind the unstructured format is social media data became very high, that everybody will upload a video, and to manage that we need to have a separate database, and where HDFS and MapReduce came into picture. HDFS for storing the data and MapReduce to process it. When MapReduce was not or was unable to process real-time data, Spark came into picture and it replaced MapReduce. So this happened in early 2010, 11 and 12, where most of the companies migrated from traditional data warehouse to big data warehouse. And when I talk about big data lake, there is a difference. Any idea what is a big data warehouse and data lake by any chance? Kavya, any idea? By any chance, what is a data lake and a data warehouse? What is the difference between them?
Not so sure, but it's
You can answer whatever you know.
Okay, data warehouse is having everything in it, like whatever databases or like any other tables. It's like a
Okay.
collection of tables and
Okay,
databases.
agree.
It's actually, yeah.
Correct. Agree.
And
Totally agree.
data lake is like, as far as you know, it's like a connection for data to transfer from one database to another.
Okay.
I don't know if it's correct or
Half
no.
part is
I only
no, that's fine. That's fine. It's okay. It's okay. Half part is correct. So whatever you mentioned about data warehouse is correct, because we get from data from different sources and we load the data into a data warehouse, which is a another database. When I talk about
Yes.
data lake, right? A data lake is also a data warehouse with real-time data. That's it. So
Okay.
it contains both historical data plus real-time data. See,
Okay.
there is no much difference between data warehouse and data lake. Data warehouse will have only historical data, whereas data lake will contain historical data plus real-time data together. See, what is
Okay.
meant by a lake? A lake will have a continuous flow of water, right? Correct or not?
Okay. Yeah.
Similar to that, a data lake will have a continuous flow of data, which is called live streaming data. Example, whenever you swipe your credit card, your transaction will become live transaction, right? Do you agree that?
Mhm.
Assume you lost your credit card, for example, and someone started using it. So the bank has to block the transaction. Do you agree that?
Mhm.
Your credit card, you lost it, someone started using it, and whatever the transaction that going to happen, and you already informed the bank to block them. So the bank has to do on fly whenever they swipe the card. Do you agree that?
Yes.
For example. So to achieve that, we cannot go and wait for 1 week and store and 1 day and store the data, right? On fly,
Mhm.
immediately I need to capture the transaction and I need to block that immediately. That can happen only if I capture live data. Do you agree that?
Yes.
That is where big data lake will come into picture, or data lake. So data
Okay.
lake will have real-time transactions plus historical data as well together. One more example: when you go to Amazon, for example, when you buy any particular product, as soon as you finish selecting the products, and when you move to a cart to pay the money, before paying the money, they will recommend you some products. Correct, right? Why can't you
Yeah.
buy these two products together like that? So that kind of thing can happen only with the real-time analysis of your actions. Correct, right? How do they know
Yes.
that you like those products? Correct, right? They will have a recommendation engine which is called real-time recommendation engine. So on fly, they will track your actions. For example, they will try to see which pages you visited and which products you selected. So according to that, immediately they will go and recommend you few products which you may like. So this can happen only if they will capture your real-time actions, or your behavior in the website, or your interest. What are your interests? So these kind of applications can be built only if you are able to capture live streaming data and you have a big data lake available, or data lake available. I hope you understood the difference between data warehouse and data lake now.
I got it.
Yeah, yeah. So any particular e-commerce companies nowadays, or any banks, they are leveraging their big data lakes to monitor their customer transactions in real time. Any credit card transactions, when you do, sometimes you will receive a call from the bank. Correct, right? They will call you and they will say, is the transaction your transaction are suspicious? This kind of actions will happen because they track your actions in the real time. And even e-commerce companies also will track your actions in their website to recommend you some products. So to achieve that, we need to have a big data lake. So as the conclusion here is, as a data engineer, you should be able to process not only batch data or historical data, we should be able to process even real-time data also. Okay, that is what you need to go. So when I talk about what are the sources for this particular big data lake and big data warehouse, the data will be internal company's data will be there, which is in the form of tables and rows and columns in the databases. Plus, they will have some CRM applications data will be there, every company, and plus social media. After big data came into picture, after 2010 only, social media became part of the data engineering. Before that, there was no social media at all. And before 2010, in the big data warehouse, we were only having structured form, like rows and columns. As soon as we move to big data lake and big data warehouse, we got semi-structured and unstructured data also. So both are added to your data sources. And every company started integrating the structured, semi-structured, and also unstructured data into their big data environment. And what is the required knowledge to build these big data lakes? It was mostly Java that time, and most of the people may not be interested to learn Java, right? That is the challenge. Even if I ask you to migrate to big data engineer and ask you to learn Java, it may not be easy for everyone, and everybody may not be interested, and they will hesitate to learn these tools, and like MapReduce, Spark, many tools came into picture after big data came into picture. So the challenge here is to any data warehousing engineer to migrate into big data engineer is so many tools you need to learn. For example, you go and see if to become a big data engineer in 2010, 12, 11, and 12, people need to learn all these frameworks. Is it easy to learn these many frameworks? No, right? Many frameworks came to the market after big data came into picture. So most of the frameworks, whatever you see here, these are all part of big data, and every big data engineer need to learn almost all these frameworks to maintain their big data warehouse or big data lake. So that it became very challenge to a data warehousing engineer or to adapt to big data. The same way, companies also were facing challenges to maintain big data because big data ecosystem was fragile and which was most frequently getting changed. And maintenance also is very hard because you need a separate Hadoop administrator or big data engineers to maintain that environment, and you need to pay them. So they are very costly also during that time period. So finding a technical resource and performance optimization, all these are very challenging. So companies started thinking like for alternative solutions also during the time period. Why? Because managing Hadoop cluster is not easy. You should be a Hadoop administrator, and you will find very limited resources to do that, and limited people who knows that particular technologies, and you cannot find people who knows all those technologies. One person cannot do all this. Very you can find very rare resource will get to know all this, and the rare resource means high salary also. These are all challenges companies were facing after big data came, and even to reuse the people who already worked on conventional data warehouse and ask them to migrate to big data also is not easy because everybody may not be interested. Then how Snowflake is becoming the next generation of big data? The main reason why companies are moving to Snowflake from existing big data is majorly like in big data side, you need to know either Java or Scala or Python. That is the main challenge. And also, if at all I want to go with like a Snowflake, if I know SQL, that is sufficient. I do not need to know any extra language. So because it's very easy to learn, and if for any extreme use cases only, you go with Python. Majority use cases I can use SQL and I can solve it. And even in big data side, it supports structured, semi-structured, and unstructured. Even in Snowflake also, I can go and use the same. So Snowflake is capable to process any kind of data now, and any live streaming data I want to process in big data side, usually we use Kafka. The same Kafka connector is available even in Snowflake now. And product stability. So stability wise, if you see, big data ecosystem is not like small. It is a fragile and it will be frequently changing. So no, maintaining that is not easy. So you need to know DevOps, and you need to know so many tools, and you need to maintain them, and patching, upgrading, all these are very difficult in big data side. Coming to like Snowflake side, everything is integrated in single product, and all the maintenance like patching, upgrading, or any installations, all this stuff will be taken care by Snowflake team in the background. We as a user do not need to worry about how to upgrade or how to maintain that. We simply will log in and use it. Simple. Maintaining the product is not our responsibility. Also, transformation side. Any idea what is the transformation? Any chance? In ETL, we extract the data, transform, and load it. While extracting the data, we do extract from multiple sources. After extracting and integrating them, we try to apply some transformations on that, and then we load into the target. So these kind of transformations, majorly in big data side, you need to go and leverage a PySpark or any framework to apply that, and you should be an expert in PySpark. But in case of Snowflake, you do not need to write any code like PySpark. You can simply use already tools available in the market, which are UI tools. Like we have like DBT, we have like Matillion, StreamSets, PolyCTL, Fivetran, and also like IACS, Informatic IACS, many tools already in the market which you can leverage and you can go and perform all your ETL jobs in these tools, and we can integrate with Snowflake very easily. And data size, if you see supported size, big data side, definitely it will be like infinite, nearby infinite, because big data is designed for a large amount of data. Similar to that, Snowflake also offering unlimited data to store and unlimited data to process. That is the biggest benefit with Snowflake. And resource availability also, if you see for Snowflake, it is easy to find because we can easily find people and teach them who knows SQL, and we can easily train them. But coming to big data side, it is very hard to find out the people and train them, because everybody will not be interested to learn these many tools. So salaries also, if you see, extremely high. If you know Snowflake, DBT, and Airflow, you can see how the jobs are in the market. And coming to big data side also, it's very high, because if you know those many tools, ultimately you will get good salary. But at the same time, if you even know SQL and Snowflake and DBT and Airflow, these tools also companies are paying the similar salaries. And use cases wise, big data basically designed for only real-time systems, whereas Snowflake is designed for both real-time and batch systems. Real-time and batch in the sense historical warehouses. Now, why I need to go for Snowflake? There might be so many reasons. People ask me why I need to go for Snowflake. The first and foremost thing is Snowflake is very simple. The simplicity, plug and play. No need to install anything. Serverless, and I can simply create an account, create a user and password, and log in and start using it. Within 2 minutes, I can create an account and create username and password, and immediately log in. I can start using it. That is the benefit with Snowflake. That is called simplicity. Like our Gmail account, how we create and log in, right? Similar to that. Second thing, scalability, which means that there is no restriction that the number of users that I can connect to Snowflake environment, or number of, like the amount of data I can store in Snowflake. There is no restriction at all. And amount of workload I can go and run. I can run hundreds of queries. There is no restriction on the scalability side. And even if at all I want to increase the size, I can easily do, which is called elasticity, instant elasticity. No need to depend upon any DBA. We ourselves can do that. That is the benefit with Snowflake. And a flexible cost. Flexible cost means just like our postpaid. You can use and pay as you go. So whatever you are going to use, you need to pay for only for that. No need to pay a single extra penny for what you are not going to use. And diversity. So diversity will come like where you are going to store your data in one location, and you can access from multiple locations. So all this making Snowflake unique in the market, and every developer in Snowflake developer will leverage these particular features, basic features, and making Snowflake unique in the industry. Now, if I go and talk about architecture wise, Snowflake follows a traditional architecture, which is a multi-cluster shared data centralized architecture, where I can go and create multiple clusters, and which is quite opposite to our traditional architecture, which is shared disk architecture. And we can go and find Snowflake is following the modern architecture only. And to summarize, Snowflake, we can call it as a data warehouse as a cloud service. We do not need any hardware to install, configure, and manage. No software is required to install, configure, or manage. Just ongoing maintenance, everything will be, management will be taken care by Snowflake team in the background, because Snowflake will continue completely will run in cloud infrastructure. No need to install anything. So you can call it as a serverless product and software as a service, like our Google Drive or OneDrive or Gmail. How this will work, similar to that, Snowflake also will work. And apart from that, Snowflake is providing like other features like security and data protection. Like we can integrate Snowflake with the multi-factor authentication, single sign-on. These features are also applicable, and it follows a standard ANSI scale, which usually every database will follow. So if you want to learn Snowflake, if you know SQL, it's very easy to learn. We can learn very fast. And as part of this training, I'm going to cover SQL also, so which you can go and refresh yourself. And the connectivity side, it contains so many connectors like for every tool. Like you have like Tableau connector, you have a Spark connector, Python connector, you have like Power BI connector. So you can connect to so many tools, and by using Snowflake, because Snowflake is allowing to connect to any tool. And we also providing data storing feature, which I can share my data with other Snowflake accounts. So this I will discuss in detail in the further classes. And most of the like Snowflake environments will look like how you can see here. You have multiple sources here, and that which is a combination of structured and semi-structured and unstructured. Every source will be integrated by using ETL process, and it will be on top of any one of these clouds. It doesn't mean that Snowflake will run on all the clouds. You will select of your choice, like either AWS or GCP or Azure, while creating the account. Ultimately, it will go and select that appropriate cloud to store your data and manage your data. After you centralize the data, you can build all these kinds of applications. I can build a data warehouse, I can build a data lake, or I can perform data engineering. I can also connect to Snowflake Data Exchange. I can also perform data science in Snowflake too. As soon as you centralize your data, the consumers also will be like so many people. Data science team will be there sometimes, or it can be like a dashboard team who will connect, who will perform real-time dashboards, or some data analysts will be there who will connect and pull some data for their analysis. So Snowflake will allow you to connect to any particular target, and they can leverage this data and build their own applications as well. And most of the like Snowflake projects or architectures will look like almost like this. I can show you. This is one architecture where you can see most of the tools here. You will see like the data is coming from a particular website. Snowflake is able to we can capture that by using AWS S3, and from S3 it is pushing to like Snowflake environment. In between, we are using Matillion here. So as I mentioned, Matillion is one of the tool which becoming very popular now, along with DBT, like and other tools. So people, most of the companies are who are affordable to buy license of my Matillion, they are using that. And we can even replace here Matillion with DBT also, which is open source. Okay, we are going to learn DBT, which is the open source for this particular training. And as soon as your data is loaded into Snowflake, we can go and build any machine learning or Tableau. We can connect to any other tools and build your like applications also. Okay, and apart from this, what is needed to start your career in Snowflake? To start your career in Snowflake, usually people who knows SQL, they can learn very fast, because most of the commands will be SQL only. If you know any database, you are good to go and learn, and Snowflake is very easy for you to learn. And if you have a data warehousing fundamental knowledge, that also will be an added advantage. As part of this training, I'm going to cover the data warehousing fundamentals and SQL fundamentals also. If you know any ETL or any one particular like database like Oracle or SQL Server, that also will help you to learn faster. Cloud knowledge is not mandatory, because we are not going to use 100% cloud, but what is required for managing Snowflake, we are going to learn. I'm going to teach you that. And coming to like other tools are how to move forward in your Snowflake career. Along with Snowflake, you can learn any one of these tools. We are going to learn DBT here, which is also popular in the market, and we are going to learn Snowflake and DBT. Also, we are going to learn a bit on Airflow as well as a combination, and we are going to learn even Python also as part of the Snowflake learning to manage 4 or 5 use cases using Python and Snowflake, because most of the jobs nowadays they are asking about Python as well. So I'm going to cover even Snowflake Python connector too. And Snowflake job market also, you can see it is growing, and it is almost like it was in 2022 itself, it was very high. Now you can see how the market is growing. And as per this particular training, we are moving like with a project based training, where you are going to learn with use case, not like a feature wise, so that you will understand like how it will be utilized in real time environment. And also we are going to learn not as one sample project. I'm going to demonstrate and explain you like 3 to 4 projects which are in real time, how it will be in real time, and we are going to cover that. Also I'll try to like help you to prepare the CV if you are looking for, and I'll try to guide you, and that will help you to like even see how the market is looking, and the CV and all. I'll try to guide you, and that's about like at high level how Snowflake is like unique in the market. And if at all I want to start using Snowflake, you need to go to like Google and simply search for, it is very fast and we can easily create a Snowflake account. Go to Google and search for Snowflake free trial, and it will prompt you this particular link. If you click on this, it will be redirected to Snowflake environment. Here I can create my free account within 2 minutes, not even 2 minutes. You need to provide your details here, like your first name, last name, and your email. To provide everything, it will go and prompt you to like select which cloud you want and which edition you want. You can select enterprise, and you also can select AWS here. And once you select this and check the checkbox, it will move forward, and it will go and ask you to do some security check. You need to do that. So you can skip that, you can skip that, and skip that, and so once you finish it, that your account is ready now. You will receive an email, so where you need to go and check your account. Snowflake team will send you one activation email. So this is the email. When you click this, it will prompt you to activate your account. So this email will receive, you also will receive the same kind of email. Once you click on this particular URL or click activate, then it will prompt you to enter your username and password. And once you enter your username and password, you are done. So your account is ready, and you can log in and start using this particular Snowflake environment. I'm going to teach you in detail one by one, so where you can go and understand about how to go and leverage this particular environment step by step. So where you learn about each and every feature in detail, and which I'm going to cover. And this is like a training which is basically not like feature training, it is a task based training. And after you enter your username and password, you will move to a interface called Snow Site interface. This interface will help you to run your commands, and to run your commands you need to go and use a worksheet here. Worksheet is going to help you to run your SQL commands. So this is the SQL worksheet. Here I can create my databases and however I want. Create a database demo. So when I run this, it's going to create a database, and a database demo got created. You can see in the left hand side it got created. It's very easy. So the commands are almost SQL commands, and every command which you are going to run, that is basically a ANSI SQL command, and we are going to learn them one by one with feature, and I'm going to teach you like how it will be utilized in the real time environment. I hope you got some fundamental idea of what Snowflake, and how to go and create a Snowflake account also. But as per this particular training, we are going to cover Snowflake plus DBT as a combination with real-time Snowflake tasks, which we are going to learn along with AWS is our particular cloud here. And whenever we are going to learn about this particular Snowflake and DBT, sometimes people are asking Azure Data Factory also. So I am trying to cover ADF also, not all the Azure services. ADF with DBT and Snowflake also I am covering, where we learn SQL as a fundamentals here, SQL basics, and apart from that, you will also learn Snowflake features like Snowflake architecture and Snowflake, how to connect with Snowflake, different ways to connect, and what are roles and users in Snowflake, and you need to know that. Also, Snowflake is very strong in compute side, so you will learn about virtual warehouses in Snowflake for that. And once you finish virtual warehouses, we'll move to database objects, like how to create tables, databases tables, also like how to create multiple other database objects. And we also will learn about time travel and failsafe, which are part of like Snowflake, very unique to Snowflake, and how to restore your data when you delete accidentally, and how to restore your tables which you dropped accidentally. In normal traditional databases, we cannot go restore it if a table is dropped. If you drop a table, you lose the data. But in Snowflake, we have an option to restore the data which you already deleted or dropped. So Snowflake is going to provide that feature. That is part of Snowflake time travel. And zero copy cloning is another feature which will help you to create copies of your database without additional storage. When I go and see normal traditional databases, your storage, for example, for development database is 1 terabyte. And if you want to create a copy of testing and another QA, you need to go and need additional 2 more terabytes. But in Snowflake, zero copy cloning will avoid using additional storage. So I can create a copy of the dev database with testing and QA without additional storage. So that will save your storage cost. So that is how zero copy cloning will help us. And then you will learn about internal stages and external stages to load the data into Snowflake. And we will learn about how to load the data from local to Snowflake environment by using data loading, and how to load the data back from Snowflake to S3 bucket or local. We are going to learn with the data loading and unloading part. And then we'll try to see how to integrate Snowflake with AWS, and how to load the data from AWS S3 bucket, and also from Azure blob storage as well. And that is 2 types, batch loading and continuous loading. I'm going to cover both, and that is part of data loading part. And also, while loading the data, you will not only load CSV files, you also will load semi-structured data like JSON, XML, Parquet, ORC, and Avro as well. We'll try to learn each and every file format, because every client may not give only one file format. It will vary from client to client. So we'll learn all the file format to load the data. And once after you finish loading the data, we also will learn streams and tasks to perform the incremental loading into data warehouse. And once after you finish that, we'll go and learn about data sharing, one of the important feature in Snowflake, to how to share the data by using secure shares, and as well as views and other features, and data masking also. And to perform programming constructs, we'll go and learn about stored procedures and UDF functions here, which are very important, and I'm going to cover that. And performance tuning, this is also important, where whenever you go to any database, how you are going to optimize your particular environment and speed up your queries. We need to go and understand about this concept like query tuning, clustering, and micro partitions, and material use. I'm going to cover as part of performance tuning. And masking policies, and how to mask your sensitive data. If you go to any bank, especially my bank, they are very particular about data sensitivity. So how to mask your data, that you are going to learn with low level masking and column level masking. And finally, I will go and learn a little bit about date and timestamp columns in Snowflake. Once you finish here Snowflake, then we'll jump into DBT also. And DBT is one of the tool people are asking majorly, most of the companies. So we need to know how to integrate DBT with Snowflake. We are going to learn about that. And also ADF and Snowflake integration also I'm going to cover. Once you finish all these topics, we are going to learn 3 to 4 projects with all features which we learned. And any other additional things, if I feel is important, I'll cover them at the end, and also provide interview questions and resume building also. And whatever you are going to learn in this particular course is going to help you to like crack a job in Snowflake in the market. That is what how we designed this particular course. Now this is for your time to ask questions, and you can ask now.